It's chemistry. In this lesson, we'll go over the rules for naming ionic compounds. So ionic compounds consist of a cation, that's the metal, and an anion, the nonmetal. When naming ionic compounds, the cation is named first and retains its original name. The anion is named last, and the end of the anion's name is changed to IDE. So here's some examples. If the metal is sodium and the nonmetal is chlorine, then the cation is sodium, retains its name. The anion becomes chloride. So the compound is NaCl and the name is sodium chloride. If you take potassium and fluorine, the cation is potassium. The anion becomes fluoride. That's Kf, and the name is potassium fluoride. Magnesium and oxygen. The cation is magnesium. The name stays the same. The anion, it becomes oxide. The compound is MgO, and it's magnesium oxide. Lithium, sulfur. Lithium is the cation. The anion becomes sulfide, and that's Li2S to balance the charge, and that's lithium sulfide. Some transition metals may have more than one charge state. So for example, iron Fe, if you look at your charge number by ion sheet, it can either take on a 2+ or a 3+ charge, meaning that the atom loses either 2 or 3 electrons. When naming an ion with more than one charge state, a Roman numeral is used in its name. So I is 1, II is 2, III is 3, IV is 4, and V is 5. Iron can form two different compounds with oxygen. So the first one, iron, the nonmetal oxygen. So if it is iron 2 with a 2+ charge, it would be called iron with a Roman numeral 2. The anion would be oxide. So the compound would be FeO because it's a 2+ and 2- charge for the iron and the oxygen, so it just becomes FeO, and that's iron 2 oxide. That's the way you would say it. Now the other charge of iron also bonds with oxygen, so that would be the 3+ charge. So you designate that by using the Roman numeral 3, so it's iron 3. It also is oxide, but now the compound is going to be Fe2O3 because the iron is a 3+ charge, the oxygen is a 2- charge. You cross the arrows and you end up with Fe2O3. So the name would be iron 3 oxide. Here's some more examples. Copper and fluorine. So we're going to use the charge of copper. Again, these have more than one charge of 2. The anion is fluoride. The compound is CuF2 because you need 2 fluorides to balance with the 1 copper 2+. So that's going to be copper 2 fluoride. Titanium and chlorine. So titanium can have more than one charge. This is going to be titanium 4. Chlorine is going to become chloride. So you need 1 titanium to balance the 4 chlorides, or 4 chlorides, a 1- to balance the 1 titanium 4+, and that's titanium 4 chloride. Cobalt, bromine, so we're going to use cobalt with a 2+ charge. Bromine has a 1- charge, it becomes bromide, so it's cobalt Br2. 2 1- equals 1 2+, so that's cobalt 2 bromide. Now, there's some unusual names that you may come across. We're never going to use them in class, but there's an alternate nomenclature for transition metals with 2 main charges. The lower charge, the number uses the suffix us, O-U-S. The higher charge, the number uses the suffix ic. So let's just look at some examples. So FeO, we saw that earlier. This is the Fe2+. so it's iron 2 oxide, so that's ferrous oxide. That's the lower of the two charges. The higher of the two charges, which is iron 3 oxide, is Fe2O3. We saw that on the last slide, and so that's ferric oxide. Copper, this is the higher of the two charges. That's copper, excuse me, that's copper, it's the lower of the two charges. That's copper 1 oxide, so that's cuprous oxide. The higher of the two charges is 2 plus, so that's copper 2 oxide, and that's cupric oxide. Next, we have lead sulfide. So lead 2 is on the lower of the two charges for lead. Again, you find this on your charge number of ion sheet. So that's going to be plumbous sulfide. And then there's lead Cl4. That's going to be lead 4 chloride. And so that's the higher of the two lead charges. So that's plumbic chloride. SNO is tin oxide. So it's tin 2 oxide is the lower of the two tin charges. So that's stannous oxide. SNF4 is the higher of the tin charges, which is a tin 4. So that's going to be stannic fluoride. And one more, mercury 2O, that's mercury 1 oxide. It's going to be mercurous oxide, and this one is mercury sulfide. That's mercury 2 sulfide. That's going to be mercuric sulfide. Now here are some properties of ionic and covalent bonds, so I just thought I'd put them here. It's a good place to put them, that you should know. So the unit for ionic bonds is called a formula unit. For covalent bonds, it's called a molecule. It's a separate, independent structure. Bond formation, ionic bonds pass electrons, covalent bonds share electrons. The elements involved in ionic bonds are metals and nonmetals. In covalent bonds, it's 2 or more nonmetals. The physical state of ionic bonds, they exist as solids, whereas covalent bonds can exist as solid, liquid, or gas. Think of water. Solid water is ice, liquid water we just call water, and gas we would call steam or vapor. The melting point. Generally, ionic compounds have higher melting points, above 300 centigrade, and for covalent bonds, they melt at a lower melting point of below 300. Solubility, ionic compounds are highly soluble in water. Covalent compounds are not highly soluble in water. And conductivity, how well they move electrons and move electricity. It's very good in ionic compounds only if they're dissolved in a liquid, not if they're solid. For covalent bonds, they do not do a good job of conducting electrons. All right, so that takes care of this lesson on how to name ionic bonds.